All right, we left off on these four responsibilities, and let's just get right into the CPU. Um, the purpose of the operating system, as it relates to the CPU, is to schedule time for programs, or you can think of that as applications or apps with the CPU. Now, for most of this discussion, we're going to assume a couple things that are not completely true, but we're going to assume something just to make it a little more simple. That you only have one CPU in your computer. Now, that's not exactly true anymore, and we're going to get to that one even on this screen. But for the most part, I want you to think of most of the computer work that your computer does as being done by one CPU. So the way it handles scheduling time is we have to cover three different ways it can schedule. Although I need to be careful when I say that because the next slide will also be four ways to schedule. This is four concepts in scheduling. One is multitasking. I think every student has told me at some point, I can multitask. I can listen and play a game, or I can listen and do my other homework. I can do two things at one time. Well, not debating that at the moment. It's probably not true very well, but not debating at the moment. We're talking about computers. A computer is only capable of calculating or performing one step or instruction at a time. Okay, so if your Excel program needs to add up 50,000 numbers, it has to send that calculations to the CPU, and it performs those one after the other. However, at the moment your Excel is running, if your antivirus is trying to check for a virus in the background, it also needs to check with the CPU. So multitasking is a process that was developed back in the probably the well, I'm not going to say it was the first developed, but it first became very widespread with computers in the early 90s. I'll tell you a little bit about how it worked before that. But basically what it does is it appears to run more than one program by rapidly swapping between 2 or 100 programs. So it looks like you're running 10 programs. In actuality, only one of those is actually talking to the CPU at a time. So the CPU performs one calculation and then quickly switches to another program and quickly switches to another program, and it does it so fast. Remember, this thing is happening a billion times per second. So it does it so fast that, yeah, it looks like your game is running at the same time as your video is playing, at the same time as antivirus is running, at the same time that you're typing a paper in Microsoft Word. All that appears to be running at the same time. Now, that is if you have one processor. Multiprocessing is when you use more than one processor to run more than one program at a time. So when I first started teaching, it was very rare for someone to have multiple processors in your computer. And it's still rare to have two complete processors, but if you look at the picture to the right there, that's a modern day CPU, and you may have heard phrases like multi-core or dual core or quad core. And basically what they're doing is Moore's law is dying. If you remember from the past section, Moore's law says we can put more and more transistors in the CPU every 18 months. They're running out. Some people have already said they have stopped. Moore's law has already died. Remember, it was never a law. It's not a physics law. It was just a prediction by the founder of Intel 40 years ago. One telltale sign that is failing is that Intel has stopped telling people how many transistors are in their CPUs. So that's a good sign that they're not keeping up. So in order for you to get more and more computer power, they're moving to another way of doing it. They are putting essentially 2, 4, and maybe 8 processors in your computer instead of just one. Not the entire CPU, but just kind of the math part, the important part that does the calculations. So if you can see in this example, there's 4 cores. Now they share a lot of stuff. So it's not 4 complete processors, but it's 4 calculators that share kind of some memory. And I'm simplifying, but that's okay. The problem with this, and this is a good thing, but the one downside is not everything in your computer fully uses all 4 if you had 4. There's modern processors that came out just in the past couple of months that have 8 and 12 of these cores, and that does not mean your computer is going to get twice as fast or 4 times as fast, because if they're not evenly used, and if this one's used a whole lot more than this one, then it won't be that much more beneficial. And I'm going to show you some examples here in a moment of different ways these cores are utilized. And thirdly, on this big picture concepts of scheduling is parallel processing, and sometimes you'll see the word distributed processing. I'll take either term. And that means you're splitting up a program and you're actually sending it to a completely separate computer. If I don't get to in this video, I have an entire demonstration of how that works, but basically think of a job that would take, one program would take 3 hours to calculate, but it's possible that if I had 10 computers, I could send that job, split it up, send it a little piece to each of the different computers, and then each of them just report back to me the answer, and they've done all the math. That'll make more sense once I show you an example. It has to do with how videos are created, or films are created, computer graphics are created. So let's return. We're going to come back to these two terms, but first let's talk about multitasking. How does a computer multitask? There are 4 ways a computer will multitask. I'm going to teach each of them individually. In reality, all 4 of these are happening at the same time. And that, again, I'm going to show you examples in Windows how all these terms kind of are working. So these are 4 techniques for multitasking. The first one, I'm going to name all 4 of them and then come back and explain how each of them work. First come, first serve, priority based, shortest job next, round robin. Okay, so let's talk about this. And I think the easiest way to demonstrate this, and I've always used this same example, it seems to make sense to me, so hopefully it does for y'all as well. Think of someone who needs to use the phone, and there's only one phone to go around. So you have a couple different ways this could be handled. First come, first serve. If the phone is sitting there, whoever walks up to the phone first takes the phone, calls whoever they want, talks for 20 minutes, hangs up, and the next person who walks up gets to use the phone. Whoever's there first. This is how we treat, restaurants. When you go into a restaurant and you're waiting to be seated. I know there's some nuances to different size tables, but actually applies a little bit to how computers are scheduled as well. But it applies when you go to McDonald's and you get in line. It's first come, first serve. It doesn't matter who you are, how important you are. You're going to get to the back of the line and work your way to the front. So let's think of it this way. Excel wants to use the computer. I should say use the CPU. So Excel sends a job to the operating system. The operating system checks no one else is actually using the CPU at the moment, which is actually kind of rare because it's always in use. It sends a calculation. While it's in the middle of calculating, your Microsoft Word sends a request for the CPU to do a calculation or to work on a picture that you've added. In other words, it has to wait. If Word gets there after Excel, it has to wait. If your calculator program or your antivirus, whoever gets there has to wait. This is not a great option, so it's blended with these other techniques, but it's a start. Okay, does that make sense? So whichever program comes first gets to use the CPU until it's done, and it moves along, the next person gets to use the CPU. Number 2 is priority based. So priority based means everything works just like number 1, first come, first serve, unless you have a higher priority. So if you're using the phone and someone else is standing there waiting for the phone, and you, as let's say there's an emergency, you have to call 911. You go up and say, it's an emergency, I need to call 911, and that person is going to gladly hand you the phone and you're going to take over. So priority based means if your job is more important, you get to take over. This would be important in situations where you have, think of computer programs that are monitoring vital signs during a surgery. It doesn't really matter if the computer's mouse needs to be updated as far as its position on the screen. If that blood pressure changes on the screen, an alarm needs to go off. It doesn't matter what's going on. This would also be a situation when you think of NASA and when they sent astronauts to the moon. If there's a life critical application that needs to take priority, it's going to take priority. It's going to jump ahead of everything else. Okay, I'm going to show you in a moment how all that works in even Windows. Shortest job next. You're on the phone, you're calling someone, you have a 20-minute conversation going on, and someone walks up and says, I just need to call someone. It's going to take 12 seconds. I just need to call them and say, I'm here, I've arrived, don't worry. Maybe at school in the morning, you're just calling your mom saying, I'm here, don't worry, bye. And it's a short job. Some people actually apply this to their homework at night. Have you ever gotten home and said, okay, I have to write a research paper, I have to do 25 math problems, and I have to answer 5 questions in science. Which one do you do first? Some people have no plan. They just sit down and whatever book comes out of their book bag first is what they do. Some people, you know what, I'm going to get those 5 questions out of the way. That way, no matter what happens, that job is done. And then I'm going to tackle the next shortest and then the longest last. So this actually is a common scheduling method with CPUs. So if there is a job it knows that it's going to be short. If you are rendering a 7-hour movie and an Excel needs to calculate 1 cell, it can jump ahead. It's not a great example because many times it's swapping back and forth. Anyway, well, I'm going to get to that in the fourth one here. Because round robin is actually kind of takes priority over all of these. Round robin says, I don't care how long your job is, I don't care who got here first, everyone's sharing. It's the fairest way of doing this. So now this is where the phone analogy doesn't make a lot of sense because this would not be practical in real life. But you have a 20-minute phone call. You have 1 minute and you have to hand the phone to the next person. They have 1 minute and they hand the phone to the next person. Now, when you hand the phone to the next person, you go back and get in the line because eventually you're going to get another 1 minute because you're not done. And the phone just swaps back and forth 1 minute, 1 minute, 1 minute, 1 minute, around and around and around until eventually you're done. And then whoever's left by themselves, they can finish because there's no one else waiting. So, and that's the first go-to scheduling method. Just give everyone equal time unless you have a priority based or sometimes a shortest job can interfere. Let me open up a program that I want you to, and you can pull this up on your computer as well. If you hit Control Alternate Delete and hit Start Task Manager, let me move it over to your screen. This is a program that comes with Windows that allows you to see a couple of different things. And this is where we can kind of see some of these applications in and how they actually are working with Windows. The first thing I want you to look at is the CPU number here. That is the percentage of the CPU that is busy right now by that program. So for example, idle means it's not busy. My computer is only 25% or so busy. Avast is an antivirus. It must be doing something because it's using 13% of the CPU. OBS is the software I'm using to record this. So even though it's recording constantly, it doesn't require a lot of CPU calculations. So it's jumping around and dropped down 5-7%. My Chrome browser, it is using 3%. I've actually found that programs like YouTube, Facebook can really shoot Chrome up to higher percentages. So this is a little misleading because even though these all say 0, they're actually like 0.02. So they're actually very small percentages, but it just rounds to 0. So all these programs are running on my computer at one time. All of these programs. Let's right click on, let's say OBS, and you can go down to set priority. And this is where you have features like real time, high, above normal, normal, below normal, and low. Low means I want you to run, but only do this if nothing else is going on. Let anybody interrupt because it's just a feature that's not that important. Real time would be like that blood pressure monitoring program during a surgery where you need to, check their vital signs in real time. And real time literally means billions of a second in response time. So there is that kind of scheduling priority based. You can see it there. Round robin, it's just running all the time. Um, and you can see priority based there. I want to quickly look over at performance, and you can kind of get an idea. I mentioned earlier that not all cores are used, so there's 8 cores, so to speak, in this computer, and this core, for whatever reason, is not being used very much. This one's not being used quite as much. The second, third, fourth, and fifth one are a little more. So this is good. That means they're fairly balanced, but what you want to see is all of them equal. That means you're really dividing up your work. Um, so that is the 4 methods or the 4 scheduling techniques that I want you to know. The other students are going to be doing a project that involves like a problem where they have to schedule something. I'm going to skip over that since you only have 3 days, and that's going to be one thing I think would make sense to skip over to save time, because it just kind of demonstrates how the scheduling works in a more practical way. But I think that's I'm going to stop the video here because I'm going to go back in the next video and talk a little bit more about, well, I kind of just did talk about multiprocessing. That's showing the eight CPUs there, the 8 cores. That's an example of multiprocessing. Parallel processing, I'm going to save for the next video because I have an example of how that's going to work. That's kind of I think, an interesting demonstration of that. So from this video, remember those 3 terms here that are the 4 concepts involving scheduling, and then the 4 actual methods of scheduling, and how they all multitask. Remember, all of these are assuming that there's just one CPU. Where this changes things is when you actually have 8, and they can do round robin with all 8 of them, and you can see how that makes your computer run a lot faster by not having to share. So I'm going to start in the next video talking about parallel or distributed parallel or distributed processing, and then there's a few other concepts about CPUs and companies that manufacture CPUs that we'll get to in the next video.